Hello, good day. Medyo pagpasensyahan ang babang resolution ng aking camera. Pero this is a pilot presentation wherein I'm trying out a couple of applications for me to be able to uh, survive in the new normal, sabi nga. So, in this particular pilot episode, I have decided to present the topic in physics, and the title of the presentation is Adding Vectors Graphically. I've explored a couple of applications for me to be able to present freely, and in order for me to be able to showcase features that you don't need expensive applications for you to be able to survive in the new normal. In this particular presentation, you will be learning about adding vectors graphically. And for us to be able to add vectors, we need to consider that it could be represented as rays in a Cartesian plane. So ideally, you should be able to draw a Cartesian plane. You should be able to represent a particular vector using a ray diagram, and a ray diagram that represents a vector ideally could be described both as, number one, its magnitude is represented by the length, and second one, the angles represent the direction as to which the vector is pointing. So say this is a Cartesian plane, and we are to consider the following examples. So, and we are to add vectors F1 and F2. F1 is 20 newtons north, and F2 is 30 newtons east. And our task is for us to be able to add F1 and F2. And the sum of F1 and F2 is called the resultant force. So first, let us draw the Cartesian plane to represent our vectors. Say, we can consider a particular scale so that the graph that we are to use will fit a particular size of paper. Example is 10 newtons is to 1 inch. So kung medyo malaki ang measurement, we can have it resized, and that's the purpose of using scale. So say the scale is 10 newtons is to 1 inch. And one of the methods that we are to use, in particular for adding vectors graphically, is called head-tail method. And in the head-tail method, we first draw the first vector, say F1, which is 10 newtons north, there. And then we draw the second vector using an imaginary Cartesian plane that considers the end of the first vector, which is the head, and we draw the second vector from that. And the second vector is 30 newtons east, so that's where you'd find vector number 2, F2. And finally, the resultant vector, which is called resultant force F sub r, can be drawn from the origin up until the end of the second vector, or the last vector that you have considered. And in this case, it's F sub 2. Yeah. And that's represented by our purple arrow, or purple ray here. And the label is F sub r. And for us to be able to finally describe our resultant force using magnitude and direction, as we know, force vectors in general are described by both magnitude and direction, we can use a ruler and a protractor, since what's introduced in this particular discussion is graphical method of adding vectors. There, I prepared an enlarged version of the case for us to be able to better visualize how you'd be able to use your ruler And using a ruler, you'd be able to see that the measurement is about 3.6, about 3.6 inches. 3.65 inches to be precise. And using the scale, we can multiply 3.65 by 10 newtons and we can get 36.5 newtons as the result. As to the direction, we can use a protractor. Again, we look at the resized version of our example. And using a protractor, you'd be able to see that the direction is about 32 degrees north of east. As to the direction, you can express direction in a couple of ways. Say you can have, instead of using the measurements east to north, you can have this direction from north to east, which simply is the complement of 32 degrees. So 90 minus 32 is 58 degrees east of north. And one of our ideal answers is 36.5 newtons, 32 degrees north of east. That's it. In this particular presentation, you were able to see that you can add vectors graphically using a Cartesian plane, ruler, and protractor. And a summary, in this presentation, you were able to learn that vectors can be represented as rays. The lengths of the rays represent the magnitude of the vectors and the angles represent the direction. In this lesson, we have also determined the resultant vector through graphical method, specifically the head-tail method. Thank you.